Welcome everybody to the Unit 1 CFA 1 Cycle 1 Geometric Transformations quiz. This is the Ed Puzzle version of the quiz. So you'll take this quiz and you can have resets on this quiz. And we're left with question number 1. Triangle ABC is translated 8 units right and 4 units down. 8 units right, 4 units down. What's the location of A prime? So we want to take this point A right here, and we're going to try and go, we're at -3. So that's 3 to get to here, plus we need to go 5 more. 1, 2, 3, 4, 5. That'd be your +8, because we wanted to go 8 to the right, and that affects the x coordinate. And then we want to go from that point 4 down. 1, 2, 3, 4, and that's where your A prime is located, -4, because that's how your y's are affected, and you're going down. So what is the location of this point? Problem 2. Triangle ABC is reflected over the y-axis. Okay, we have a reflection over the y-axis. What is the location of your B prime? So here's B, and your y-axis is here. Y-axis is here, and we want to reflect over that. So it looks like it's a mirror image, and we know the rule over the y-axis is that your x's and y's, when you reflect over the x-axis, the y-axis, your y is going to stay the same because you're going in this direction. So we want to have our negative opposite of x, comma, y. So in other words, also, you know that this is the line of reflection, so it's 6 units to the line of reflection, so it needs to be 6 units. 1, 2, 3, 4, 5, 6 units. It's over here. That would be your B prime. 3, the pre-image is dilated from the origin. Okay, we have a pre-image. You need to find that. The pre-image is here. And here's the origin. We have a dilation K that we're looking for. What's the dilation K from the pre-image to the image? Well, here's our image right here. Pre-image to image, and dilated from the origin. So here we went from, let's look at these coordinates, -2, -5, and then they are larger. So what is how much larger is it? How do you go from -2 to -4? -2 times what K factor gets you to -4? Remember, because X's and Y's, when you're from the origin, go to KX, KY. Problem number next. If the pre-image was dilated from the origin by a factor of K equals 1/2, or another way to write that is 0.5, what's B prime going to be? Well, let's find B. Okay, and so we're dilating from the origin. So what do we need to do? We need to know that your X and your Y, in this case, your X is -3. You're going to apply the rule. And for each of those coordinates, you're going to multiply by 0.5 times your X, 0.5 times your Y. So what is -3 times 0.5 times -3? That's your X, your new X coordinate, and 0.5 times 1. That'll get you your new coordinates of B prime. Triangle ABC is reflected over the y-axis. Okay, here's our y-axis. What is the location of B prime? Well, here's B. We have a very similar thing that it's reflecting over this Y axis. Here's our Y axis right here. So again, the rule says what happens with your X's and Y's when you reflect over the Y axis is that the Y's don't change, but your X's go opposite. So that would put your B prime, it's traveling here, takes 6 to get to the line of reflection. 1, 2, 3, 4, 5, 6. Where's that point located in space? Next problem. What sequence of transformations would not map the pre-image to the final image? Let's take a look here. And we have 3 possible solutions. We can rotate clockwise 90, rotate 90 degrees clockwise, then reflect. Well, one of these first 2 have to be wrong. Let's see. The third one must be correct. Let's check it out. Rotate 90 degrees counterclockwise, reflect over the y-axis and translate. So if I rotate 90 degrees this way, reflect, and then translate, that's going to be fine. Let's look at the top one. Rotate 90 degrees clockwise. So from the origin, a 90-degree rotation is somewhere about right here. Then we're going to reflect to here, to here. It looks like we're off a little bit. It looks like if that's A, we're going to have to take it over somewhat to the right and down, possibly down over 2, down 1. That should get us right there. So we needed to reflect not over this one says reflect over the y-axis, but this is the x-axis. So this one is the one that is, the second one's the one that's incorrect. The pre-image is dilated from the origin. What is the dilation factor K from the pre-image to the image? So now we have to look at, let's take a look at point C and point C prime, because we're dilating from the origin, and we see that C is at -2, 5. So what would we have to multiply times K times -2, K times 5? What would K have to be to get you to C prime where you know it's -1, 2.5? What does K have to be? So what number times K equals -1? What would, I'm sorry, times -2. What do you multiply times -2 to get to -1? What number times -2 equals -1? What number times 5 gets you to 2.5? Notice that your ending number is smaller than this number. So you have to multiply by, you can't multiply by a large number, it has to be a small number. And we have almost over here. The pre-image to image 1 has undergone a rigid transformation. Here's our pre-image and image 1. Okay, what transformation has been performed? And we have to figure out what this is. It looks like it can't be a reflection, because if I reflected this, A prime would be over here. That's not the case. If I translated it from here, the orientation wouldn't be right. So I have to do what? I need to rotate it 90 degrees, and in which direction? Which direction? Next, image 1 has undergone a transformation to image 2. Okay, so we see it looks like a mirror image here. If it's a mirror image where we have things are equal distance away from this axis, and it maintains its congruency, which transformation is it? Is it a rotation, a reflection, or a translation? Those are the rigids. And finally, the essential question. How do you know when two congruent figures are congruent? And we think about that we need rigid transformations. They are translate, there's reflect, and there is rotate. Now remember, these are rigid. So under these transformations, congruency is maintained. And that means that you can map one image to we could say one pre-image to an image. But the most elegant way to say this is that two figures are congruent if a series of rigid transformations can be used to map one figure to the second. Now, this question also comes up at the end of Unit 1 CSA as a 2-point answer. So it's something that you really want to know. Okay, well, hopefully you did well. And if you need to do any Ed puzzle resets, you need to email your teacher at George Garrigus, that's an I, at MaderaUnified.org. And good luck.